So just here again, focusing on the consistency in the pipeline. This is covered pretty extensively in the Humble Farley Continuous Delivery book. There's a famous blog article by Randy Bias of this original, pets versus cattle, which is, do you treat your servers as pets? Do you name them? Do you take care of them when they get sick? Do you nurse them back to health? Or are they just you cattle where you kind of number them, and when they get sick you kind of you get rid of them. But here's the thing, like when you get into containers, right, this is even more important because you literally can roll clusters and automatically kill containers because you're running hundreds, maybe thousands of running containers in a cluster. So consistent environments in all stages. You want to create. The goal is to take consistency, right? In the early days, we used. I say early days. Early days, it was all checklist based or somebody's shell script that was somewhat inconsistent. So the way you build it in your kind of laptop or development environment was kind of different, or maybe somebody missed something because they were manually running from the checklist or wiki in the integration section, which might have been different from in production, how production was built. And then Chef and Puppet came in, and CFN Chef and Puppet came in and created a high level of consistency where all the environments would get built at every level through some DSL, domain specific language. But now we're finding, and again, I spent a lot more time on this in the previous class, but this immutable delivery model where literally people build their container images on their laptop, and they basically binary artifacts that start the pipeline immutable and then run all the way through the pipeline to production as immutable. In other words, if it went green from when it left the developer's laptop, it was bit for bit the same in production. So there's even no variation in how you build even something like a Chef or Puppet. A very, very interesting model. But at the end of the day, all elements of the pipeline should be disposable and reproducible, right? And then all environments should look like production, right? From laptop to integration to any type of testing. You want to decrease variability between elements in the pipeline, right? Again, the Docker model is immutable, right? It's almost like, I can't say it's completely reduces variation because obviously there's host stuff, and without getting to the details of Docker, if you don't know it, the containers actually run on a Docker host, right? So the host itself could create some inconsistencies, but the images themselves, for the most part, again, mileage always varies on how you configure things. But repeatability, increasing speed, rebuilding environments, reduce errors related to inconsistencies, increase security related to inconsistency. In fact, there was a great quote today, and I'm really going heavy on the container stuff, but I talked to a large insurance company today, and their motto is, if you containerize it, you get security for free. And I know that's going to blow a lot of people's mind. I'm going to have a lot more information about this throughout this year, but it's actually now that there's actually enough data to say that actually running application services in containers can be, depending on how you configure it, certainly with Docker, can be more secure than actually virtualized instances. You version control everything. Therefore it keeps a history of all your changes. You can check the differences between. You can restore, rebuild elements. Things can be tagged. All changes are visible and audited by everybody. So again, the magic really starts when everything's in version control. There's a commit SHA tag. That thing, again, using the container model, that stuff can go into the container. But at the end of the day, you literally can track, where it came from. Was it, static analysis, static code analysis? When was it? Was it vulnerability scanned? What was the output of the integration tests? Pass, fail. It gets really exciting. And is a general. It's funny. Somebody early on who was taking the Intro to DevOps course, they were like. They were kind of shocked that I put this list out, and I was like, it's 2000. Now it was 2016 when I wrote that class, but now it's 2017. You should not be shocked by this slide. This is standard operational procedure. All application, all configuration scripts, any DSL of any configuration management, images that build containers and VMs, metadata, config like your JSON, your YAML, your TOML, your automated tests, your test scripts, your test DSL code, your Cucumber, Selenium, whatever you're using. Your documentation. GitHub now can support PDF. I mean, now it's been a while now, but PDFs or your documentation, all that stuff, and documentation as code, right? I mean, or documentation to the if you're using any kind of a templating, CloudFormation, Terraform, the OpenStack Heat, or any templating for network switch configuration definitions, right? Database schemas, DNS firewall. I mean, it's just the list goes on, right? Basically everything should be in configuration. And then there's the infrastructure as code, and there's an interesting kind of balance now between, what really requires infrastructure as code. Again, we go back, 8-10 years, right? This was groundbreaking that people were moving from, manual or what I used to call Bob scripts to this very mature kind of DSL, something like CF Engine, Chef, and Puppet with idempotent infrastructure, all sorts of these really desired state configuration. And so there's just a balance now between people who are building purely container immutable deliveries, but the world needs, you still need to build your hardened container servers. So in the world, it's your Docker engine, right? And there's a lot of configuration. So things like in Chef and Puppet for building the overall infrastructure and how you build out complex environments of orchestrating, even in a container world, becomes still a very important discipline and tool structure that needs. I've spent a lot of time over the last couple of years talking about immutable delivery. Gartner has a really good thing about Docker and software delivery use cases, which really spells out how the strength of Docker and container delivery. And then I wrote an article kind of based on, it's a Docker white paper actually now, based on Gene Kim's The 3 Ways of DevOps, and showed how an immutable delivery model really fits pretty well in there.